what we call indeterminate form. Now let's do some more intuitive kind of computations. Not really computation, just guessing here. Um, for most of the part, we are doing some comparison. I should say, comparing the size of A and B. Okay, so in this thing, we're comparing this one here. Okay. So if the ratio is, so both are positive. Say, positive. Okay. When this ratio is small, for example, suppose, what can you say about this one? Or is it large? What can you say about A and B? When this ratio A over B is small, what can you say about A and B? So, are you with me?
Yes, sir. I still don't quite get understand the concept. If A and B,
A over B. You're comparing the size. You're comparing the sizes of A and B. Well, we're comparing just computer fractions, A over B, for example, ratio, compare the ratio. If the ratio is small, what can you say about A and B? Uh, so this is small. What can you say about A and B? Or it is large. What can you say about A and B?
A is small while B is large.
Yes, that means if it's small, then B is larger. Then that this is large. Oh, sorry. If this is small, sorry, this is large, then the other way around, right? So A is larger than B. Okay. So then let's take it to the extreme. This is the context is calculus. Okay. So when something is not is zero, the limit is zero, it doesn't mean that the number is zero. It's just close to zero, right? So let's see. Uh, so if you have something that looks like this one, limit, for example, Okay. I would say this is small. A and B is small, really small. Okay. So what can you say about A and B? Same thing as buff. Limit 0 means this is really, really small because in the context of calculus. Okay. So this is still true that B is larger than, but it is more than just larger. It is B is much larger than A, or A is much smaller than B. Okay, so in this case, I should say its limit is like for example, it's like a microscope. Okay, so you see this is, so for example, you're comparing the size of virus and a bacteria. Okay. Okay, so in our perspective, without the microscope, is well, both are small, but how small are they? Okay, so with microscope, you can say this. Well, virus is much smaller than bacteria. So in that case, limit is actually our microscope. Okay, so that's why I'll say this is an intuitive just idea. Okay. All right. So in this case, if you compute something like this, 0, okay, this means A and B are small. But in this case, small, because x going to 0 anyway, 0 plus, let's say, positive. But in this case, how about this comparison, this 0? The fact that it is 0 is that because A is much smaller than B. Okay? So first thing is, you may have a different situations. There. Now I prefer reading this as large. Okay. Now because x going to 0, that is the case that we are comparing virus and bacteria. This is the case of how you call this? Uh, Microscope. So means A and B are small, but B is much smaller than A. Okay. Do you understand the intuitions of here? Okay. All right. So here is, you're comparing bacteria and virus. Right? If you put virus as A, bacteria as B, B is bacteria. Okay. So you get 0 because virus is much smaller than bacteria. Okay. But if you put the other way around, so you put bacteria at A and virus at B, you get this because virus is much, bacteria is much larger than fibers. Okay, and let's put another way around. All right, so now we don't have microscope. What we have telescope. We try to observe two stars. Okay, it is hard to compare stars. What? What? And with naked eye, right? So you need a powerful telescope to discern what's the difference. Okay, I suppose so. This means A and B is large. Why large? Because this. Okay, but now the ratio is zero. Why zero? What does it mean? It's zero. Well, just because B is much larger than A. Okay. And if you put this, if that's infinity, means A and B is large. All right, so because this, can you hear me now?
Yes, sir.
Okay, so it's bad connection.
sure.
Somehow it's disconnected. Okay, so that's X is big, so that's A and B are large, but then the limit is infinity, large, I would say. That's because A is much larger than. All right, so we have two situations, four situations. A and B are small, right? But one is much smaller than the other one, or much bigger than the other one. This gives you this limit. Zero means small in this case. In the constant calculus, infinity is large. Okay, so this is the main idea if behind what we'll do in indeterminate forms. Okay. All right, I should stop here. We'll start the material tomorrow, but this is the key idea. And the thing is, we will try to compare A and B more precisely, how big and how small. Okay. And let's see, what else? All right, and I should give you a quiz tomorrow. Well, on item pools, that is basically multiple choice. I would give you a bunch of integrals, not to compute in the integrals, but you're guessing the method of the integrals, okay? So for example, I give you 10 problems. You should do one problem just in maybe just 10 seconds, 15 seconds to decide whether it is, which method you use. Okay, so we have quite a few methods, and the key idea is how to be able to see what method you should use to solve the integral. All right, so that's tomorrow. I have to open. I forgot to open the attendance this morning, but I opened it until 10. Okay. All right, so I'll stop the record.